hopefully everybody can hear the sound in this video, or at least they're watching me point at this sign and getting their sound up and running. This is the lesson for section 4.6. That's chapter 4, section 6 in the Geometry Chapter 4 study guide. So, the first example basically says that you have a pair of docks. Here's a dock here and a dock here, and positions that have been marked at the end of the docks that are closest to each other. And then ropes have been strung out so that C is the midpoint between this marker at the end of dock A and this point E. And it's, let's see, actually, I'm sorry, C is the midpoint between the marker at the end of B and D. So basically this side and this side are the same lengths. And then we've got some perpendicular things here. We have BD perpendicular with DE, and let's see, marker AB perpendicular with BD. So this one is also perpendicular here. Okay, so the whole reason for this whole arrangement is that what they want to do is figure out how to find the distance between the two docks. So between dock A and dock B. Now that would be hard to do with a boat, or, you know, just kind of throwing a line across. This is a way where you don't have to go out in a boat, you don't have to swim across, you don't have to, you know, do anything out in the water. When you create two triangles that are congruent, which these are, because these two lines are intersecting straight lines, this angle right here would be congruent with that angle right there, we would be able to establish that these two triangles are congruent because of angle, side, angle congruence theorem. The angle here and here, the sides here and here, and the two right angles here and here. So in the bottom triangle you have angle, side, angle, and the top triangle you have angle, side, angle. Now, once you know that two triangles are congruent, then you know 6 things. All 3 pairs of angles are congruent, right? So angle A is congruent to angle E in this example. Angle B is congruent to angle D, and angle ACB is congruent to angle ECD. Okay, that's in this specific example. And just in general, when you have two triangles that you know are congruent, you know that all 3 pairs of sides are congruent. So in this particular example, you would know that AB is congruent to ED, and BC is congruent to DC, and CA is congruent to CE. So, if you're ever asked to prove something really specific, if you're asked to prove that, you know, this side on the triangle is congruent to that triangle on the side on the other triangle, what you actually have to do is go through the entire process of figuring out what theorem would prove the two triangles overall congruent. In this case, I chose angle, side, angle. And then once I've established that the two triangles are congruent to each other, then I can list any of these 6 things to be true. I can state that any pair of angles that correspond are congruent, or any pair of corresponding sides are congruent. So it's important that you understand that there's a 3-step process. So proving your two triangles overall congruent from the given information, and then making the statement that something more specific can also actually be true. So basically, the second phase of that whole process is called saying, we basically, the reason for the statement that any of these things are true because these two triangles are congruent would be saying that any corresponding parts of congruent triangles are congruent. So that's why angle A and E are congruent, or side DC and CB are congruent, because they're corresponding parts across two congruent triangles. Now we're going to abbreviate this as CP-CTC, corresponding parts of congruent triangles are congruent. And I've always found that this can be more easily memorized with some sort of mnemonic device. So like something like cool people, care for their community, or any other CP-CTC acronym that you want to come up with. So, if you want to prove that there's a certain side length that's congruent to another side length, what you're going to have to do is the 2-step process. First, prove that the two triangles are congruent, then you can make the statement that any pairs of corresponding parts would then also have to be congruent. So it's kind of like doing the proofs that we did before, and then just making one more statement at the end, tacking on the more specific parts. Okay? So looking at this diagram, it seems like I've got angles right here, SPR, congruent with RQS, and I've got ST, that's this length here, congruent with TR, that length there. So basically I have two triangles. I have PSR and SRQ. I'm not the best sketch artist in the world. I'm trying to make them proportionate to one another. I think that's about the best I'll do for today. Okay, so if I first have to establish that the two triangles are congruent, then I can establish that PR is congruent to QS at the very, very end. Those are my two phases of explanation and proof. How could I first then, in phase 1, show these two triangles are congruent? Well, I have a side here, SR, that's congruent with its corresponding side over here. And then I have this angle up here, P, corresponding with this angle up here, the Q. So is there anything else in this diagram that could be demonstrated to be congruent? Well, I would say that we have PT. Now, assuming this is a isosceles triangle down here. Isosceles triangles, we know that if you have the two sides that are congruent, the opposite corners from those two sides would also have to be congruent. So I would say that this corner right here, that one, and this corner right here, that one, would have to be congruent because of the definition of an isosceles triangle, which is this triangle right here, STR. So we would have side, angle, angle. I think that works nicely. So I'm going to go ahead and say that we have all that we need to establish using the side angle angle congruence postulate for triangles, that the two triangles are congruent, triangle PSR and QRS. Once I've established that those two triangles are congruent, then anything that matches up that I want to state, for example, PR and QS, I can state that those are congruent because the two triangles in the last statement that I made were congruent. Okay, so they gave us angle SPR congruent with angle RQS, and line segment ST is congruent to line segment TR. Reason being that was just given information. And then I'm going to say that angle SRP is congruent to angle RSQ because of the definition of an isosceles triangle. And so I have two pairs of angles and one pair of sides where the side is not in between the two angles. So that would be angle, angle, side. So these two triangles, triangle PSR and triangle QRS, must be congruent because of the angle, angle, side congruence postulate. So that's phase one. That's the first major step. We want to show that the two triangles are congruent. Once we've done that, once we know that we have two congruent triangles, then we can state that any of the corresponding angles and any of the corresponding sides will then have to be congruent. But we just have to do this step first. So now that we've completed phase one, then anything else we want to state in terms of the specific little parts going across from side to side must be congruent. So now, even though PR and QS originally were not marked congruent, we can now state that they are. PR must be congruent to QS because of the thing we've just said in line 3. Because we know their triangles are congruent, then the corresponding parts, whether it be two sides like this or two other angles like these two, then we could go ahead and state that all the rest of this corresponding, these corresponding elements must be congruent. So we use corresponding parts of congruent triangles are congruent, CPCTC, or cool people care for their community, as the reason. This is my reason. This is my shortcut way to think about it. Phase one, and then phase two. Establish the triangle congruence, then you can say any parts that match have to be congruent. Alright, on the next page we have some triangles, and they want to know which postulate or theorem I would use to show that BC and AD, for example, are congruent. Well, I would say that AC is congruent to itself. I would say that this angle right here is a right angle that matches with that angle over there, and then I have this side marked congruent with this side. So on the bottom triangle, I have side angle side, and on the top triangle, I also have side angle side. So first I would show that these two triangles are congruent by side angle side congruence theorem. Then I would say that side BC is congruent to side AD by the corresponding parts of congruent triangles are congruent. So this will be my phase 1, and then finally phase 2 would just be to make that statement. Example number 2 has triangle TSU. How do we prove that congruent with triangle VSU? Well, I have an angle matching up with an angle here. I have another angle right here, the 90-degree angle, matching up with this 90-degree angle. And then I have a side that matches itself. So on this triangle, I have angle, angle, side. And on this triangle, I have angle, angle, side. So by the angle, angle, side congruence postulate for triangles, those two triangles are congruent. TSU and VSU. Triangle ABD, or ADB, can we show that that is congruent to triangle CBD? Well, I have a side up here, congruent to a side down here, side over here, congruent to side over there. And then finally, this side is congruent to itself. So on each triangle, I have 3 sides that correspond and are congruent with 3 sides on the other triangle. So according to the side, side, side congruence postulate, I'd be able to show that those two triangles are congruent. Now, write a plan for the proof. Well, first you have to figure out what theorem you're using. So that's ultimately what the plan is. And then you can figure out what kind of things you want to establish to make that theorem true. Kind of those two things. What do you want to establish? What are the elements? And then what's the overriding theorem that you're going to rest those elements on? Okay, so triangle DAB and triangle BCD. Okay. Well, I have this side right here, congruent with this side right there. I have some right angles, and I have this side right here. And then I've got this angle up here and this angle down there. Now, here's the problem. On each one of these triangles, I have angle that's not in between the two sides. Side-side angle or angle side-side is not a theorem. So even though I've established two sides and an angle that are congruent, unless the angle is between the two sides, I can't use that theorem. So what in the world do I do? Well, there aren't any other parts that I can prove congruent based on what I've been given. So what do I do? Well, I'm going to erase these. Now remember, there are 5 different theorems. 4 out of the 5 include sides and angles. And then the 5th one has to do with only right triangles, which is what this is. And that one said that if you can establish the hypotenuse of one right triangle to be congruent to the hypotenuse of the other right triangle, and a leg on one right triangle congruent to a leg on the other right triangle, then you can use something called the hypotenuse leg congruence theorem. So with this, the only thing we'd have to do is establish, because we've already got our hypotenuse here congruent over there, the only other thing we'd have to show is that the leg is congruent with itself. So my plan would be to show that BD is congruent with itself by the reflexive property. So there's my theorem that I would want to use, and that's the one thing I would have to show in order to get there. And then I could say the two triangles are congruent. Now, this, I just want to say that this is kind of out of order. If you started with DAB, then it would be CBD, BDC. So this congruent statement is a little bit off, but I just went ahead and assumed that they had intended to write it the right way. Okay, what's our plan for number 8? Well, I have a side here, congruent to a side matching up side down there, the corresponding side. I have an angle here that matches, is congruent with an angle down there. And then, let's see, I see that the only other information I have to work with is the fact that these two lines are parallel. So if we have two parallel lines and then this line is the transversal, what I also see is that this angle right here would be congruent to that angle right there. So those two are called corresponding angles, and corresponding angles are congruent. So on this triangle, I would have angle side angle, and the same thing in this triangle up here. I would have angle side angle. So I'd have a pair of congruent angles and a pair of congruent sides that are in between. So my plan is to prove that these two triangles are congruent by the angle side angle theorem. And the way I would do that is I would say that I would try to establish that angle RST, that's down here, is congruent to angle PRQ by the corresponding angles theorem. Okay, now this would be my phase 1, because at this point I will have established that the two triangles are congruent. And then in phase 2 I could say, okay, now that I know that these two triangles are congruent, then all the corresponding parts, all the corresponding sides and all the corresponding angles would match. So since ST, that's this side right here, is in fact corresponding with side RQ, now that I know the two triangles are congruent from phase 1, then in phase 2 I can say that ST would have to be congruent to RQ by the fact that they are corresponding parts on two triangles that up here I just proved were congruent. Okay, a couple more examples. So if we start with the fact that yx is congruent to xw, that this side is congruent to this side, and we know that zx bisects the triangle yxw, so it cuts the whole triangle exactly in half right here. Then what do we know? Well, I would say that if this is exactly halfway through this triangle, I would say that this side over here would have to be congruent to that side over there. But I don't know, it just looks that way. I can't really think of a theorem that would have to establish that, because really we're just cutting the triangle in half exactly. I'm not really sure what the angles are. I mean, it looks perfect, but I think what I can say for sure is that this angle up here would have to be cut exactly in half. So I would say that this angle would have to be congruent to that angle. And then between these two triangles, this is the common side. So I would say that this side would have to match with itself. So that's, I guess, the direction I would go. So I'm looking at these two triangles, half on the left and the half on the right. And in order to prove ultimately that this side corresponds and is congruent to this side, well, we know it corresponds, but we have to show it's congruent. In order to do that, first I'd have to prove that this triangle is congruent to that triangle in phase 1. And then I'd be able to prove that the corresponding parts, which include YZ and ZW, are congruent. So my plan is to use side, angle, side. On this triangle, you can see I have side, angle, side, where I have two sides and the angle in between. Two sides and the angle in between. So I'm going to use side, angle, side. And I want to prove that this side is congruent to itself. So that would be XZ is congruent to itself. And I want to prove that angle YXZ is congruent to angle WXZ. And I'd be able to do that because this line is bisecting the whole triangle. So, here's my givens. Okay, what do we start with? Well, let's start with the easy one. XZ is congruent to itself. And that would be the reflexive property. It states that anything reflexive, anything is always congruent to itself. And then I wanted to use the angle here because YX bisects the whole triangle. That means that those two corners would have to be congruent. So angle YXZ would be congruent to angle WXZ because the definition of a triangle bisector, bisect means to cut exactly in two equal pieces. So I have two pairs of corresponding sides I've proved to be congruent and one pair of corresponding angles that I proved to be congruent. And I can see in my diagram that the pair of angles is in between the two pair of sides. I have side, angle, side, if you look at each triangle individually. So statement number 4 is I can state that triangle YXZ is congruent to triangle WXZ because of the side, angle, side congruence theorem. And then that is phase 1. All of this is phase 1, right? All we're trying to do is show that this triangle on the left is congruent to that triangle on the right. Once we've done that, we can state that any matching parts, any corresponding parts then have to be congruent. So we could say that this angle matches this angle, we could say that that side matches this side, and so on. This angle matches this angle, whatever we want. So what we were ultimately trying to prove is that YZ is congruent to ZW. Those two now are corresponding parts on triangles that we just said were congruent. So we can go ahead and state that YZ must be congruent to WZ because they are corresponding parts of congruent triangles, which makes them congruent. Corresponding parts of congruent triangles are congruent. And the last proof for this section is this one. So to prove that something is a midpoint, we actually have to take it a step further into kind of what I might call a phase 3. I think these two triangles have a pair of sides that are congruent and a pair of angles that are congruent. So what I would want to do to prove that B is the midpoint between D and C is first show that this length here, BD, is congruent to this length here, BC. there's nothing I can automatically state that would be true. The only way that I can state that this side and this side are congruent would be to state that this triangle is congruent to that one first. That would be phase one. Then I'd be able to say in phase two that this side would be congruent to this side. And then if these two parts are equal, then B must be the midpoint. That would be phase three. So that's my overall plan. So phase one is just figuring out how to prove these two triangles are congruent. I have two angles and I have two sides. I need one more pair of something. The only thing I can see here is that this angle here is congruent to that angle there because they're vertical angle pair. So I would have an angle and an angle congruent pair. So on each one of these triangles, I would have an angle, angle, side, angle, angle, side. And that's a theorem. That's one of our shortcut theorems to prove triangle congruence. Two angles and a side not in between. That works. So I'm going to use angle, angle, side. And I'm going to prove that angle ABD is congruent to angle EBC because of the vertical angle theorem, congruence theorem. So here we go with our proof. Phase one is trying to prove the two triangles are congruent. So they told me that AB is congruent to BE and angle ADB is congruent to angle BCE. That was given. Then I said that I see these two angles that are congruent. Angle ABD is congruent to angle EBC because they're a vertical angle pair. And so I have two pairs of angles and one pair of sides not in between. And so that would be the angle, angle, side. Congruence postulate for triangles that would allow me to state that triangle ADB must be congruent to triangle ECB. So that's phase one, proving that the two triangles are congruent. On this one, phase two, we're trying to eventually state that point B, right here in the center, is the midpoint between D and C. Now, first we'd have to show that side DB and side BC are congruent. Then we can say that B would then have to be the midpoint between the two endpoints. So the next thing I can state is that DB has to be congruent to BC because on these two triangles, DB, see that right there, is a corresponding part with BC. And corresponding parts on congruent triangles then have to be congruent. Corresponding parts on congruent triangles are congruent. And you can tell that they're corresponding even here the way we've marked it. This side it goes from the single angle to the double angle mark, and same thing here, single angle to double angle, so they'd have to be the corresponding sides of two congruent triangles from step 3. Okay, so once we know that this length here is the same as this length here, then we can say that B would have to be exactly in between D and C. That's called the midpoint. So B is the midpoint of DC. That's based on the definition of a midpoint. When you have a straight line and you have two pieces on each side of a point in the middle that are equal in length, then that point in the middle, B, would have to be the midpoint. So here's phase 1, proving the two triangles are congruent. Phase 2, proving those two parts on each side of the middle are congruent to each other. And then phase 3 would be making our final statement that B would have to be the midpoint based on statement on line 4.